In our last video, we learned about how to solve a system of linear equations by graphing. First, I took you over to Desmos, and then we did it algebraically by addition. In this video, I want to talk about sort of what can the solution to a system of linear equations look like. In this version, we saw that it became a single point because, not surprisingly, when you have two lines, more often than not, those two lines will intersect at a single point. But that's not always the case, and I need you to think outside the box a little bit to figure out when that's not the case. So let's get these two equations into a form that maybe is a little bit more familiar to work with, where we can see what its slope is and we can see what each line's y-intercept is. So let's take the first equation, the 4x plus 2y equals 6. And we're just going to go ahead and put that into what we call slope-intercept form. So we're going to isolate the y. That way we can see what the slope is and what the y-intercept is. So if we move the x to the other side, we have 2y equals minus 4x plus 6. All I did was subtract 4x from each side. Then we divide through by 2, and we can have y equals negative 4 over 2x plus 6 over 2, which is really y equals negative 2x plus 3. There is our equation in slope-intercept form, and if you remember, that tells us that our slope is negative 2, and it tells us that it's going to intercept the y-axis at 3, okay, at y equals 3. So we have an equation that we can make sense of. Now let's look at the other one as well. I'm going to go ahead and move this, get this out of here for a second and make some room. Let's solve this one. Let's get the second equation, 6x plus 2y equals negative 6, into slope-intercept form. So that's 2y equals negative 6x minus 6. Y equals negative 6 over 2x minus 6 over 2. Y equals negative 3x minus 3. Our slope is negative 3. Our y-intercept is negative 3. And we saw what these two equations look like when they're graphed. Okay? When they're graphed. We look at Desmos and you can see here they are graphed together, and they have that point of intersection at negative 6, 15. Okay? If we go back, let's take a look one more time. We have a slope on the first one of negative 2 and a slope on the second one of negative 3. What happens if the slopes are the same? If the slopes are the same, what happens with the slopes? The same but different y-intercept. What happens if that's the case? Well, let's go change the slope of one of these so that it's the same. So if we go back to our Desmos, you notice that we've got 6x down here. Let's change the 6x to a 4x, and that'll make our slope the same. You can see what happens. You can see what happens. They intercept the y-axis at two different points, right? This one intercepts the y-axis at 3, and this one intercepts the y-axis at negative 3. 3 and negative 3. But you'll notice, do they have a solution? Is there a solution? Do these lines ever intersect so that we can say there's a single point that lies on both lines? The answer is no, because they're parallel. So if the slopes are the same, lines are parallel. And have no solution. But what if the slopes are the same and the y-intercept is the same? Then what? Well, if we look at Desmos again, and we'll set that up, well, the slope is already the same. The y-intercept we can make the same as well. Oh my goodness. Well, they're pretty much the same. Well, they are. They're exactly the same line.